So today we are going to start. We are going to perform one experiment. Objective is SSB modulation and demodulation. Okay. So in the previous experiment, we performed about double sideband amplitude modulation and demodulation, where you saw that both of the sidebands we were transmitting and we are receiving it and demodulated it and retrieve the message signal back. So all the processes you must have seen. Okay, I also have shared the links of previous two experiment on your Google Classroom. You can access the link from there also. If you have not watched yet, then you can watch it again. Okay, so as far as SSB modulation is concerned, the name suggests single sideband amplitude modulation. Okay, so in double sideband modulation, we were sending both the bands, and we know that even a single band is capable of sending the whole information without losing any information. We can send the whole information using only one sideband. Okay. So by sending two sidebands, we are using more power at the transmitter end to send those two bands, as well as more bandwidth is required in order to send those two bands. Okay. So it means that if we are switching to a single sideband or if we are using SSB modulation, it means that we are reducing the bandwidth by 1 by 2 by I mean ki if the bandwidth used in case of DSB modulation is 2 FM or 2 omega m, then in this case we are going to use only FM, half of the bandwidth that is required in case of double sideband. As well as the power is getting saved when we are using single sideband modulation scheme, because you must have learnt about the formulas of power save. I'm not going to tell the formula, but it is expressed in terms of modulation index. You must have uh, learnt about that in your theory classes. So, in case if we are using single sideband modulation, it means that we are having both the benefits. As I told all of you in the previous classes, that for a communication engineer, the challenge is to balance between the transmitted power as well as the available bandwidth. In this case, when we are switching to SSB modulation, so in compared to the DSB AM modulation, we are using single sideband. It means we are reducing the bandwidth requirement as well as we are reducing the power requirement. So it is having edge over DSB modulation. So how we are going to generate the single sideband modulation? So in this case also, in this experiment also, we are going to have a message signal. So as I told all of you that in the laboratory experiment, we are performing it on the prototype kit. So we need to generate that message signal. In a real scenario, you are having the message signal that you want to transmit. Either it be a news or it be advertisement or it be a sports updates or traffic updates, anything. The information is already there at the end of broadcasting station, and radio jockey used to give all those information, so they have the data. But when we are trying to illustrate the process, so we need to generate the message signal also. Okay, so we are having an oscillator that we are going to use to generate the message signal, and we are taking 2 kilohertz of an audio signal as our message signal. Okay, so as far as generation of this SSB modulation is concerned, we can generate it by using two of the methods. I hope you must have learnt in your theory classes also. That one is frequency discrimination, or also called as uh, filtering method, and the second method is phase discrimination method, or we also call it as a Hilbert transform method. So using Hilbert transform also, we used to generate Hilbert transform of the message signal represented by m cap t, and using a sinusoidal component of the carrier signal, we multiply it and adding and subtracting. When we subtract the cosine component with the sine component, the Hilbert transform, you must be knowing about the expression. We get upper sideband, and if we are adding both of them, then we are going to get the lower sideband. You must be knowing all these things by using Hilbert transform method. But the method that we are using here in this experiment is a filtering method, or you can say frequency discrimination method. It means that we are using a band pass filter so that we can filter out one of the sideband and take selectively one of the sideband out of the DSB signal. So in this case, we are having this generation of DSB SC signal. It means double sideband with a suppressed carrier signal. So we are having this output and we are using a band pass filter. We are giving this output, the double sideband separate carrier output, to a band pass filter that selectively selects one of the band and allows only one of the band to pass. It means that we are going to get the single sideband only, and that signal is used as our transmitting signal. Okay, that signal we transmit as a SSB modulated signal. So in this case, we are having a message signal. We are generating DSB-SC signal and filtering out selectively using a band pass filter and getting one of the band, and then we transmit it. So in this experiment, the objective is to see how our message signal is looking like, okay, and how what is the carrier signal that we are taking, that is having a high frequency signal, okay, and as well as after modulation and filtration, how our SSB modulated signal is looking like. So in this experiment, we are going to perform modulation part as well as the demodulation part. It means that we are using two kits. We are going to use two kits, one for transmitter and another for receiver. In a very similar way as we performed our DSB modulation, we are having kits both available at the same place. So we have leverage or we have facility to connect both of them using a wired mode also, or we can use antenna mode also. So I have tried to illustrate both of the modes. We have transmitted the signal using a wired mode also, and as well as we have transmitted the signal using antenna mode also. The kit facilitates both of the modes. So we have used both the modes and illustrated that how we are going to receive the signal, and after reception of the signal we demodulate the signal. So one of the advantages of ssb is also that in case of ssb demodulation we don't need to use different type of modulator, but the modulator demodulator sorry, we don't need to use different type of demodulator, but the demodulators that we used in dsb modulation demodulation can be used directly. So we don't need to design a different demodulator for ssb reception and demodulation. So it it is also a kind of benefit in case of ssb modulation demodulation. So we have received the signal using both of the modes one at a time, and demodulated the signal and illustrated and demodulated the signal, and you can see that we have retrieved the signal or the information that we are sending from the transmitter. Okay, so this is the whole experiment that we are going to perform. In this case we are having a message signal. We are using a carrier signal. We are generating DSB SC signal, suppressed carrier double sideband. Using a filtration or band pass filter, we are filtering out one of the sideband and we are selectively taking the other sideband, and we are transmitting that signal as a transmitter signal or transmitted signal or modulated signal. So the signal is SSB modulated waveform. Okay, we are transmitting it either using a wired mode or using antenna mode. We can receive at the receiver using wired mode or an antenna mode. After reception, we are performing demodulation using a low pass filter. We are filtering the signal and we are getting the RMSA signal back. Okay, so this is the basic concept that we are using, and you must be knowing that there are advantages of SSB modulation that you need to remember that we are reducing the bandwidth by half, as well as we are reducing the power by some percentage. Okay, so you must have learned in your theory classes that in case of DSB SC modulation, SSB SC modulation, single sideband suppressed carrier modulation, the power saving is about more than 80%, some sort of 83% or something. You must be knowing that. And in case of without suppressing carrier, we get a power saving of 16% or something. So there are advantages like we are saving the power, we are saving the bandwidth, and we are communicating or transmitting the whole signal, and we are receiving the whole information without any uh, loss of information using only one band. So this is the main concept of using single sideband modulation and demodulation. So I'm going to share the Google Drive link so that you can watch. The video is of 20 or 22 minutes, I think. So you can watch, you will understand everything that I have briefed you about. And after completion of the video, you can tell me if you are having any doubt while watching the video also, then you can uh, pause the video and you can ask. I have just shared the Google Drive link for single sideband modulation and demodulation. So you can click on the link, go and watch the video, complete the video, and once you have completed the video, if you are having any query while watching the video or after completion of the video, you can discuss. You can unmute yourself and ask the query, or you can raise your hand, or you can comment in the chat box also. So we will be meeting at 3 p.m. for a query discussion. So you all can go and watch the video. Let me know if this link is working fine. You are able to watch the video without any kind of issue. So do let me know that this link is working fine. You are able to watch the video for SSB modulation and demodulation. So we'll be meeting at 3. If you are having any query regarding in between watching the video, while watching the video, you can comment or you can unmute yourself and ask. Okay. So let me know if this link is working fine. Okay. If you are having any query as I discussed about SSB, then also you can ask. You can discuss. Okay. Connecting wires were there in the experiment. So I
Yes,
illustrated the
sir.
connection
Yes, sir.
also. So we know where a student is required to know all these things and the connections. These experiment DSB as well as the SSB, there are no connections at all. There are pins where we can directly take the outputs. There are knobs using which we can vary the frequency or amplitude. I hope you understand. There are no connections at all. That's why we have, I didn't include any connection over there, but I have illustrated all the processes. You don't need to understand the internal circuitry of the thing. The block, if there is written as like this is a band pass filter with this specification, you need to know this much only. Okay, because if you remember the modulator block of single sideband modulation, you must be knowing that there is product modulator and there is a band pass filter, and these two are
Yes, sir.
cascaded. Message signal is we are giving from this side left side, and we are getting the output SSB output from the other side. If you are using
Hmm.
Hilbert, other summers and other things, you must be knowing all this. So you don't need to understand what is happening inside. You are not going to design a system. I'm not asking to design a filter or band pass filter that can work like that. Either I'm not asking you to design also a Hilbert transformer, right? So you just need to know that in SSB
Hmm.
model
Yes, sir.
we use all these things, the blocks, right? We give input, we take output. What the specification of
Yes.
this block? This is what you need to know, right? So this is
Yes, sir.
deficiency at our end also and at your end also, that you are not physically present. I wish you all to come to the college soon, and we will conduct all these experiment physically also. But I'll try to address all your queries so that we can combat this deficiency. Okay.
Yes, sir.
Okay. So 44.
Electronic kit or how
No,
the time current
about
characteristics or
see,
characteristics
see,
of that.
see. In the experiment, the Viva for Communication Lab, very basic things are asked about the experiment, about the processes. What do you mean by SSB, or how you are going to perform SSB? What is the modulation index? Other things, the basic things about all these things.
Hmm.
Tell us about some
Hmm.
modulator, modulation technique, demodulation technique. Which type of signal do you use to um, transmit in AM, or this kind of basic things. What do you mean by sampling and reconstruction? Why Nyquist criteria is required? All these things, the basic things, right? As well as sometime teacher
Okay.
used to give you a selection of a subject. When you are not able to answer this communication thing, then he asks you to select a subject that you know better, and they put questions on that subject. So you all must be aware of the things that you are studying. If you are investing 1 hour, so learn something, go with something, go you should be returning with something.
Yes.
Okay,
Yes.
45.
Thank you, sir.
45. Fahad Khan.
Yes, sir.